All right, Gen Chem kids, we are going to review balancing equations today in preparation for doing stoichiometry next time. So the last couple times we spent time doing the mole concept, doing conversions from moles to grams, grams to moles, and even molecules. We're now going to put that mole concept and those conversions that we've been doing with the concept of the balanced equation to do the math of an equation next time. So the math of the equation is called a stoichiometry. So it enables us to do something like if I started with 50 grams of oxygen and I was breathing oxygen and breathing out carbon dioxide, how many grams of carbon dioxide would I be breathing out if I started with 50 grams of oxygen? So stoichiometry is the math of converting grams to moles in the balanced equation to figure out moles of something else that we want to know about that is related in that balanced equation. Okay, so we're going to review balancing equations because we haven't done that in a while, just so that we make sure that we have that skill. So I just grabbed a balancing equations worksheet from the web, and we're going to just go over a few basics. Now, the idea of balancing an equation is we are trying to observe or obey the law of conservation of mass. So we're going to consider these reaction arrows kind of like equal signs. So what happens, or what we have over here on the reactant side, needs to also show up on the product side. Now, it doesn't have to show up exactly the same, meaning if I have carbon dioxide over on the reactant side, I'm not going to necessarily expect carbon dioxide on the product side. But the carbons from the carbon dioxide from the reactant side are definitely going to have to show up bound to something else to make something else in the product side. And the oxygens in the carbon dioxide are definitely going to have to show up maybe bound to something else on the reactants or on the product side. So we need to have the same type of atoms on both sides, and we need to have the same number of those types of atoms on both sides of the chemical equation. Okay? So the way we practice this is just honestly by doing. I think practice by doing is the best way to learn. Now, I like to look at elements one at a time. So let's look at number one. We're going to look at sodium first. So if we look at sodium, we have 3 sodiums. So over on the product side, I only have 1. So I'm going to put a coefficient of 3. Remember, everything is multiplied. Okay, we are not adding, we are multiplying. So we need to think of a multiplier to get us the same things, okay? So 3 and 3 times 1 is 3. Okay, the next thing I would like to show you is, notice that PO4, that phosphate group, they're the same group. If I have the same group on both sides of the equation, it's so much easier to balance it as a group instead of the individual atoms. So I have 1 phosphate group over here on the reactant side, and I have 1 phosphate group over here on the product side. So that works out pretty well. So let's look at potassium here. I've got 1 potassium on my reactant side, but I've got 3. That subscript 3 gives me 3 over on my product side. So I need to get 3 over on my reactant side. So I'm going to multiply this by 3. And lo and behold, look, I've got my OH group here, my hydroxide group balances with an OH group here. So I've got 3 times that 1 OH group. So I've got 3 OH groups here, and I've got 3 OH groups here as well. So that balances. Okay, let's do another. Let's look at number 2. Let me change color just to make things easier. Okay, 1 magnesium and 1 magnesium. So I'm okay here. I've got 2 fluorides. I only have 1 fluoride here. So I'm going to need to multiply my lithium fluoride by 2. And then if I look back here, I've got 2 lithiums. 2 times 1 gives me 2 lithiums. Excuse me. And I've got one carbonate group. Notice I've got a carbonate group that stays at as a carbonate group. I've got one on each side. So that balances pretty well. Okay, so I want you to try the next 2 or 3 by yourself. Pause the video and we'll check in just a minute. Okay, you ready to check in? Okay, let's get another color. I've got 4 phosphorus, and over here I've got 2 phosphorus. So 2 times what gives me 4? 2, yep. 2 times 2 gives me 4, so my phosphoruses are good. Now 2 times 3 gives me 6 oxygens. So 6 is equal to, let's see, 2 times what gives me 6? Or I could say 6 divided by 2 is 3, to give me 3 oxygens there. So 6 oxygens on both sides. Okay, let's look at number 4. I've got 1 rubidium and 1 rubidium. That's okay. I've got 1 nitrate group here, and I've got 2 nitrate groups here. So I need to go back and multiply this so that I can have 2 nitrate groups. That also means that I need to go back and multiply my rubidium now, because now I have to have 2 rubidiums on both sides. Okay, 1 beryllium, and 2 fluorines, and 2 times 1 gives me 2 fluorines. How'd you do on that one? Okay, let's look at this next one. Let's get another color. Let's see, I want to change this to green. Okay, 1 silver and 1 silver. Okay, so far. 1 nitrate group, 2 nitrate groups. So I need to multiply my silver nitrate by 2 to get me 2 nitrate groups. It also means I need to go back and I need to multiply my silver by 2 so that I can have 2 silvers. Okay, 1 copper and 1 copper. Pretty good. Okay, try the next several on your own. Let's go to 10. Take a minute, do those, pause the video, and we'll check in a minute. Okay, you ready? 1 carbon and 1 carbon. We're okay. 4 fluorines, 2 fluorines. So I need to multiply this by 2. And then 2 bromines and 4 bromines, so I need to multiply this by 2. How'd you do on that one? Okay, let's try our next one. Cyanic acid, I've got 1 hydrogen, and over here I've got 2. So I need to multiply my cyanic acid by 2. My cyanide group, I have 2 now. 2 times 1 gives me 2, and I've got 2 of them here. So that's good. 1 copper, and 1 sulfate group, and 1 sulfate group. So I just needed to multiply my cyanic acid by 2. Okay, number 8. Let's see, 1 gallium, we're okay. 3 fluorines, and 1 fluorine. So I'm going to multiply this by 3 so I can get 3 fluorines. That gives me also 3 cesiums, so I need to multiply my cesiums by 3, right? And then let's look at number 9. 1 barium, 1 sulfur, 1 sulfur, 1 platinum, 2 fluorines, 2 fluorines. It's balanced just the way it is. Don't need to do anything. Now remember, when I have these blanks here, a coefficient of 1 is, a coefficient of 1 is kind of assumed, right? Just like if you do an equation, right? That really means 1x plus 1y equals 1z, right? So even if I don't have a coefficient of 1, a coefficient of 1 is always assumed. Okay, let's do number 10. 2 nitrogens, 3 nitrogens. How do I get 2s and 3s to match? I need to find the least common multiple between 2 and 3. So the least common multiple is 6, right? So how do I get 2 times what gives me 6? 3 right here. And 3 times what gives me 6? 2. Okay, now, oh, I needed to do that on my hydrogen. Sorry, my mistake. That shouldn't be there. Now, I did multiply my nitrogens here by 2. So that means I need to go back, and the 2 is already assumed. Oh, wow, I'm getting ahead of myself. So 2 nitrogens, 6 hydrogens, 2 times 3, 6 hydrogens. All right, let's try the next 10. Pause the video, give yourself a minute, and we'll check back in there in a second. Okay, you ready? I'm going to change my color again. So here we go. 1 sodium, 1 sodium. We're okay. 1 fluorine, 2 fluorines. So I'm going to need to multiply that fluorine by 2. And then 2 bromines. I need 2 bromines. And that fixed my sodiums as well by putting that 2 in there. Okay, how'd you do on that one? Let's look at number 12. 1 lead, 1 lead. Okay, I'm going to look at the chlorines next. 1 chlorine, I've got 2 chlorines, so I'm going to double this. Now, when we make water, when it comes from a hydrogen and an OH, hopefully you can see that the hydrogen and the OH are getting together to make water. I want you to think of the water as H plus OH. Okay, so I've got 2 OH groups, and I've got 2 hydrogen groups to make water. Okay, so that means I'm going to make 2 waters here, right? I've got 4 hydrogens, 2 here plus 2 here, so 4 hydrogens. So what times 2 gives me 4? 2. And then I've got 2 oxygens for the 2 times 1 for the 2 oxygens. Okay, how'd you do on that one? Let's look at 13. I've got 1 aluminum, I've got 2 aluminums. So let's put this here to balance the aluminums. 2 times 3 gives me 6 bromines. I need 1 times 6 gives me 6, so I need to put a 6 here. Okay, 2 potassiums. I've got 6 potassiums here. So 6 divided by 2 gives me 3 potassiums. And then I've got a sulfate group here. I've got 3 of them now, 3 times 1. And I've got 3 sulfate groups here. So yeah, that's going to be a 1. You can put it there, or you can just leave it blank because 1 is always going to be implied. Okay, now 14. Look at this one. We've got carbons, hydrogens, oxygens. So when we have an equation that is just carbons, hydrogens, and oxygens, always do your carbons first. Do those first. Do your hydrogens second. And save the oxygens for last. Okay, so we're going to look at our carbons first. Okay, I've got 1 carbon here, 1 carbon here. I'm doing okay. I've got 4 hydrogens here, I've got 2 here. So 2 times 2 gives me 4. Now I'm going to look at my oxygens on my product side. So I've got 2 oxygens here plus 2 oxygens here. So 2 plus 2 gives me 4 oxygens. So 4 divided by 2, because I have the oxygens in groups of 2, gives me 2. So I'm going to need 2 O2s to give me those 4 oxygens. How'd you do on that one? All right, let's look at 15. I've got 3 sodiums, and here I've got 1. So let's put a 3 here to balance that. I've got 1 phosphate group here, and here I've got 2. So let's double that. So does that mean I need to go back and fix my my salt, my sodium chlorides? Yeah, so 2 times 3 will actually give me 6. So let's cross that out, and let's put a 6 here, because now we do have 6 sodiums. Okay, so calcium. We've got 1 calcium here, and over here we've got 3. So I'm going to multiply that by 3. 3 times 2 gives me 6 chlorines. 6 times 1 gives me 6. Okay, how'd you do on that one? All right, number 16. We're going to look at potassium. I've got 1 potassium, 1 potassium. Doing pretty good. 2 chlorines, 1 chlorine. So I need to double this, which means I need to go back and I need to fix my potassiums to match. How'd you do on that one? Okay, number 17. Let's look at aluminum. I've got 1 aluminum, 1 aluminum. I've got 1 hydrogen. I've got 2 hydrogens. So let's put this, multiply our hydrogens. That will give me 2 chlorines, but I've got 3. How do I make 2s and 3s match up? Oh yeah, 6, right, is the least common denominator. So I need 6 chlorines. So I'm going to cross that out and put a 6 here. 6 divided by 3 will give me a 2, which means I need to go back and fix my aluminums to match, right? 2 aluminums. I also need to match my hydrogens. I now have 6 hydrogens. Hydrogens, 6 divided by 2 will be 3. So I should have 2, 6, 3, and 2 for my coefficients there. How'd you do on that one? Sometimes you have to go back and redo stuff sometimes. Okay, number 18. I've got groups of 2 for my nitrogen. I've got groups of 1. So let's put a 2 here so I can have 2 nitrogens. So 2 times 3 gives me 6 fluorines. 6 divided by 2, I need 3 fluorines on this side. Okay, how'd you do on that one? All right, 19. Let's look at sulfur first. I got 1 sulfur, 1 sulfur. We're doing okay. I've got 2 oxygens. I've got 1 over here. So let's multiply that so that I can get 2 oxygens. Okay, I've got 2 lithiums here. 2 times 2 gives me 4. So I'm going to need to double that to get me 4. 2 times 1 gives me 2 seleniums, and I've got 2 seleniums. How'd you do on that one? All right, and then the last one, we've got ammonia reacting with sulfuric acid making ammonium sulfate. So let's see, I've got 1 nitrogen, I've got 2 nitrogens. So I'm definitely going to have to multiply my ammonia by 2. Okay. Now I'm going to save my hydrogens for last. Notice I've got 1 sulfate group here, and I've got 1 sulfate group here. So that's okay. We're going to keep that together. Now let's look at our hydrogens. I've got 4 times 2. This gives me 8 hydrogens total, right? So I've got 2 times 3, which gives me 6, plus 2 more, which also gives me 8. So I can put a coefficient of 1 there if I want, or I could leave it blank with 1 being assumed. Okay? All right. I hope this gave you a good review of how to balance equations. Remember, balancing equations, we are just really, honestly, trying to make sure that on the reactant side of the reaction arrow and on the product side of the reaction arrow, we have the same elements in the same numbers. They can be rebound to different things, but we need to have the same numbers of the same elements on both sides to balance that chemical reaction. Have a great day. We'll see you later. Bye.